Welcome very much and thanks for joining us today for a webinar on achieving zero trust network access with Tailscale. Today we'll be covering a couple of things. We'll be covering, first of all, why is zero trust, the current challenges that we have, and why the industry is evolving in this direction. We'll talk about what zero trust actually means in terms of what you're able to secure, and we'll go over a framework that we have for how to think about the key components of zero trust. And then we'll be talking about Tailscale and how you can implement and migrate to zero trust principles progressively using Tailscale. You'll come away with a better understanding of what key components in your organization you should consider when adopting zero trust, and better understanding of Tailscale functionality for you to try out. And we have some time for questions at the end. And if you want to use the Q&A functionality in the tool, you can do that to ask some questions. I'm Kaczorowski. I'm the Chief Product Officer here at Tailscale. I've been here for about 2.5 years.
I'm Lauren Buckman. I'm our Director of Product Marketing, and I've been here for about 3 months, 3.5. I'll be handling the Q&A channel, and just wanted to give you guys a heads up. We've got quite a bit of content to go through, so be patient, and we will get to your questions after we get through the content.
Sounds good. Let's get started. So first, why are we even, talking about zero trust? Zero trust is a very trendy phrase these days. So let's talk a bit about what it is before we can talk about why there's so much interest in that. Zero Trust Network Access, or ZTNA, is a network security framework where organizations no longer assume that an entity, such as a user or a device, on their internal network is trusted. Instead, each individual connection within your private network needs to be explicitly allowed based on more than just the source IP address. With a zero trust network architecture, trust is systematically assessed with every single access request that you make. The interest in zero trust stems from work done at Google, exploring these concepts with BeyondCorp, and has now evolved into being an industry best practice for how to do network access. In January 2022, the US government published a memorandum on zero trust principles and moving the US government's institutions and networks towards zero trust, further cementing that this is how organizations should be thinking about their networks. The drive from zero trust comes from removing the risk of lateral movement inside your network, that once an attacker infiltrates your network, they're not able to affect significant damage. Traditional network architecture relied on a network perimeter to delineate between trusted and untrusted users, such as trusted employees inside a firewall versus potentially untrusted parties outside of it. By moving to a zero trust architecture, the location of an individual, specifically which network they are on, is no longer solely what determines whether the individual is trusted, but other context is used to determine whether they can access a given application. That means that a user isn't treated differently based on whether they're working in the office or at home, at a coffee shop, or on campus. And what that means is not just treating the source of the connection as an IP address, as all the information that you have, but using a combination of the user and the device that they're on. Whether or not a given connection is allowed is dependent on who the user is, what device they're on, and what they're trying to access, and therefore whether the policy allows them to make that connection. With the zero trust architecture, there is no longer such a thing as a privileged physical corporate network. And in fact, it's getting even more blurry as we're starting to see the principles of zero trust not only apply to your corporate network, but also to your production network. I want to leave you with one more thought on how to think about the shift to zero trust. Zero trust takes the concept of trust but verify and effectively turns it into never trust and always verify. So when we talk about zero trust, we're talking about the broader shift from that traditional network perimeter-based model to instead focusing on securing resources regardless of the location that they're being accessed from. All right, so that explains a bit of why we're going there and where we're heading. So now that we understand at a higher level and the driver to move this kind of architecture, let's talk about the specific capabilities that you need in a zero trust solution. We've come up with 5 capabilities that you need to really, get zero trust and implement it successfully in your environment. And we're going to go through these in more detail. But these are microsegmentation to break down security perimeters into smaller zones, to maintain separate access for separate parts of the network, least privilege access to ensure that users only have access to the resources necessary for their current task or role, continuous verification to always verify that a particular connection is allowed, not always allow. Continuous monitoring and analysis to analyze what is happening on the network and use that information to update the policy engine. And then lastly, adaptive policies to adjust controls in your network as you learn more information about identities on your network and as threats change. And this is the most important part. There is an adaptive policy engine that ties together all the other components to actually enforce access controls. So let's jump into these. So microsegmentation. Microsegmentation is about dividing the network into smaller, isolated segments or zones, each with its own security controls. By implementing microsegmentation, organizations can create separate security zones for different types of network resources, like servers or databases versus like user workstations. Each zone can be protected by its own set of security controls and policies, preventing unauthorized access by users' devices, and therefore reducing the impact of a potential breach or like lateral movement within your network. This is also sometimes called network segmentation, but the point here is that the network is divided into zones of access with the finest granularity possible. You really want to get down to the level of like a CI server that a DevOps team needs to access or a database that a dev team needs. You're creating entities as small as possible that the user can have access to. This typically means, like I said, like an application or a server rather than like a subnet or a VPC. And that makes sense. Like think, for example, about giving a contractor access to your network. You only want to give them access to certain applications, not to the entire network. That's the same thing for your users. You want to give them access to certain applications, not the entire subnet on which an application is run. So microsegmentation helps organizations achieve granular control over their access privileges. The next step is least privilege access. The concept of least privileged access is simple. Users and services should only have access to exactly the resources they need, when they need them, and only with the permissions and access patterns that they need. So, like, what does that mean in practice? Generally, it means that the policy engine must be able to enforce role or attributes-based access controls across every resource that you have in your organization. So a member of your engineering team, for example, should have different access on your network than a member of your finance team. And that's why having that granular segmentation of your network is important, because if you don't split the network into fine-grained entities, you can't actually separate what engineering and finance have access to. You both give them access to the same subnet. And of increasing importance here is the ability to consider time as part of least privileged access, so that you should only have access to a resource for the time needed. So for example, you might want to grant your engineering team access to sensitive customer information, but they should only be able to access that when they're on call, not all of the time. Since information about your users might change frequently based on time or be continually verified, as we're about to talk about, your policy engine needs to enforce that as part of every single request. So enforcement must be very granular to make sure that end users don't even need to know what they can't access, just that they get everything that they need to do their job and nothing else. The principle of continuous verification recognizes that trust cannot be assumed solely based on that initial authentication. So that is, the trust of a user or device changes over time. So you can't just say, okay, now that this user or device is on my network, it's good. You need to continuously verify and continuously evaluate user identities, device security, and other risk factors to ensure ongoing trustworthiness. Continuous verification and continuous authentication is crucial to maintain trust throughout a session. So for example, an employee who has quit but has not yet returned their laptop should no longer be able to access the network, but neither should the device of an employee who left it at a bar and lost it. So it's really the combination of user and device information over time, which is continuously updated, which should determine access. And you first authenticate a user to access resources on your network with traditional authentication methods. So a user enters their credentials. If they match the stored information, they're granted access. But again, in a zero trust architecture, that one-time authentication isn't sufficient. So you might have the user do additional checks. You might have the user perform checks for higher risk activities like re-authenticating or using phishing-resistant MFA solutions. And the user's permissions might change as the role changes in the organization, so that access controls need to be updated in line with least privilege access. You can also evaluate a user's identity regularly for risk signals. So you might look at like user behavior, like UEBA. And if there's a signal that the user is potentially malicious, then force the user to do something like perform an additional check to ensure ongoing network authorization. Authentication shouldn't be limited just to users though, or user identities. Verifying the security posture of devices used to connect to access network resources is also equally, if not more important. For devices, you first allow a device on your network if you expect it to be there. So if it's a corporate device, which you might have, a device registry for, or a set of serial numbers, or a device certificate, or even an MDM profile. Organizations should enforce security policies that require devices to meet specific health criteria, such as having up-to-date security tools or firewalls or biometric authentication capabilities. This and other endpoint level risk signals, such as device location from its IP address, can come from like an EDR, like an extended detection and response or solution. All right, so let's talk about monitoring and analysis. In order for our policies to reflect the current state of our zero trust network, they need to reflect our current risk. So in addition to the continuous verification of users and devices that we just talked about, we need to also analyze and surface what's actually happening on our network so that we can adapt and adjust our policies to reflect reality. So your ZTNA platform should give visibility as to what's happening on the network at any time, who's accessing what, and what the scope of the network is, like what's on your network. This policy engine generally should be able to respond to both new evolving threats and incidents. This could be done with a combination of logging, monitoring, and analyzing that data. Generally, there's two sets of goals that you have here. The first is to identify and mitigate active security incidents. And the second one would be to generate or adapt your policies to prevent security incidents. So this is, to put an analogy in place, like the immune system of your organization. It's where you might share information, identify incidents, respond to them, et cetera, conduct forensic analysis in order to be able to react. Those feedback loops that come from external data like threat intel, internal data like identified security incidents, policy changes from regulation, organizational changes from users or devices leaving the org, lots of other sources of information might feed into how you choose to adapt your policies. The aspect of like generating new policies, the second aspect of monitoring analysis is the network itself. So we talked about the policies that exist on the network and the information about what's flowing in the network, but what is the network itself? What's the scope of that network? What is and is not part of the network that your security team should care about? And that's where something like discovery comes into play. So a holistic zero trust implementation would include like monitoring and discovery of assets that are on the network and uses this feedback loop to bring those resources into your policy engine. This deals with the issue of shadow IT, which over the past few years has proliferated to organizations of all sizes. And lastly, the crucial part of a zero trust network access solution that ties everything together is that policy engine. So the main component of a ZTNA architecture is a policy engine that interacts with the things you need to access and the people that need to access those things and the devices that need to access those things and determines whether a given connection should be allowed. This policy engine continually verifies that the people and devices accessing things can access them based on a bunch of inputs like who the user is, what their role is, what device they're connecting from, the state of that device, the state of the user, external inputs from intelligence sharing communities, all kinds of things. This also allows the policy engine to consider various risk signals. So, based on device security or geolocation or user behavior to determine the level of access granted. For example, if a user is trying to connect with an out-of-date device, a risk-based policy engine can automatically deny authentication. And you actually need an enforcement point to actually enforce this access decision. So taking the fine-grained resources that we have and the least privileged permissions and the ongoing information that you have, that continuous verification of your users and devices, an understanding of what's on your network and how connections are being made, the policy engine then asks, like, do you authorize this connection? What do you spit out with all this information? The policy engine needs to stay up to date. It's only useful if it's up to date. And it needs to verify both sides of the connection as frequently as possible without actually compromising the end user experience, right? Like you want your users to have a great experience when they're using the solution. All right. So now that we've talked about kind of the framework of a better idea of what a zero trust solution entails, let's talk about Tailscale and how Tailscale can help you get there. Presumably that's why you joined us today. So the more, we talked about it, having these feedback and these inputs of like what's going on in your network and feeding it back in. So in general, the more inputs in those feedback loops that you have, the more useful your policy engine is going to be. But conversely, the more inputs that you have, the more tools you're using to manage your network. And that means that you're patchworking tools together, your network gets more complex. And sifting through all of those alerts effectively makes those systems, inaccessible to leaner teams. Your end users and your employees, your contractors, your consultants that actually need to get access to your network to do their jobs have to deal now with VPNs and firewalls and YubiKeys and fingerprints and networks and software updates and MDMs and all those things. And sometimes they need to be in the office to connect to something. Sometimes they need to be on the VPN. Sometimes they need to be on a different VPN. Lots of things like calling up IT to submit a help test ticket. The whole end user experience is pretty terrible. And honestly, there's also another twist here, which is this is something we're already seeing change in the industry, With the initial advent of ZTNA, some organizations attempted to just replicate the experience of being on site to being at home, basically saying that home users effectively had to connect to the corporate network in order to be trusted. Not only does that not solve the underlying security issue, which is that the user shouldn't be trusted just because they're on the network, but that actually is more work for your team, right? You end up maintaining two solutions for how users access the network. You have the version of when you're on campus and the version of how to connect to campus. And that inconsistent experience for users is terrible, right? Like if users have a bad experience, they're going to try to avoid it, spinning up their own dev environments, sharing a link of something in Slack with a poorly implemented TLS authentication, whatever it happens to be. And that's how we end up with a lot of, shadow IT. So as an industry, we've built this large, complex security infrastructure that is designed for large, well-resourced, teams, but it doesn't really work as well when you're lean or a smaller business, and you can't even get started without deploying multiple tools. And it doesn't really matter because your employees are going to do what they need to do to get their work done, which is work around the system. Somewhere along the way, it feels like an effort to get to this ideal future state for zero trust, we as an industry kind of forgot about how to just make it work and make it work for everyone. And it needs to be practical for organizations at all sizes and with varied environments and different skill sets to be able to adopt. So, like I said, initially ZTNA has created one experience for employees who are working remotely and another for those who are working on campus. The rigors around ZTNA for remote folks increase the standards for security, but the experience has been poor and has created a standalone system for one set of use cases. So there's this concept of universal ZTNA, and that takes the same rigors created for remote workers and devices and applies them back to campus-based users and devices. So everyone has increased security, everyone has the same user experience, simpler troubleshooting, logging, all that kind of stuff, and you're managing one system, which is better for your IT and security teams. So what we're doing with Tailscale, we've been thinking about this, democratizing zero trust, for lack of a better word, so that it's available to teams of all sizes and users no matter where they are. If you have 10 remote users, you'd still be able to meet zero trust principles and maintain that as you grow. So what that means, you can use Tailscale to implement zero trust network architecture principles, even at a small scale. You can deploy Tailscale to subnets and servers, but also to containers, IoT devices, and even across sites with overlapping IP ranges. You can grant access to third-party SaaS applications via egress from the network and define granular access down to the port and protocol. You can authenticate users to your network with your identity provider like Okta or Azure AD and change access based on changes to group membership. And you can give time-bound access to production resources based on single sign-on and force re-authentication for high-risk connections. You can allow devices on your network if they're part of your device registry, and then verify device health continuously, like OS patch level or CrowdStrike risk score. You can define access policies for your network programmatically in a policy file. That's our policy engine. You can manage policies in Git to dynamically update them with changes pushed to endpoints for enforcement almost instantaneously. And then you can monitor changes to your network and connections to your network continuously with logs streamed to SIMs like Splunk or Datadog, and you can use webhooks to be notified of time-sensitive changes. So Tailscale can not only be the mesh that ties all of your devices together, but any existing tools that you have together, like Azure AD, Okta, CrowdStrike, Splunk, whatever, into a comprehensive zero trust solution. If you're not new to Tailscale, but haven't yet implemented the zero trust architecture we just talked about, that might also be because we have some new features that we're announcing in the next week. You're getting a little preview of them today. The first is app connectors that actually just launched this morning. App connectors allows you to control device and user access to third-party applications without requiring any end user configuration. You can control access to software as a service applications available over your Tailscale network in the same way that you would administer access for your self-hosted applications. So how do they work? App connectors let you tunnel traffic for your third-party hosted SaaS apps through your Tailscale network to an exit node to directly access the application. This lets you send all the traffic for a particular service over your network so that you can allow list the fixed IPs of the nodes in your network accessing that SaaS application without having to tunnel all of your users' traffic through the network. App connectors work in an HA mode, in a highly available mode, and also allow for regional routing and in-region load balancing so that a user's request is routed to the closest app connector for that service and load balanced across multiple app connectors for highly accessed applications. And second, device posture management. That'll be out in the next couple of days. Device posture management lets you collect device properties and set device connectivity rules within your Tailscale network. You can use these rules to remove devices from your tailnet that do not meet security requirements or limit their connectivity based on the properties such as operating system, version, or Tailscale client version. So for example, as part of individual access rules, you could say that only devices running a patched version of Windows can access your production server. And a device not meeting those requirements would not be able to complete that connection. Device posture measures device attributes like OS patch version, device screen lock, and disk encryption, as well as Tailscale attributes like Tailscale version. You can also use third-party attributes such as CrowdStrike device score. I want to highlight these features in particular for those who might not be, who might already be using Tailscale rather. But if you're new to Tailscale and you're not familiar with some of the other functionality we have a lot of other stuff that you can use to adopt a zero trust network architecture model. Along the dimensions that we've covered, like I said, you can use Tailscale to implement that universal ZTNA solution for your users. So you can add any kind of workload to Tailscale, irrespective of cloud or location. Your tailnet can span VPCs, containers, SaaS applications, and even embedded systems. You can segment access controls down to the smallest unit. Tailscale has default deny access rules. So you need to explicitly specify the access that you want to grant. You can allow groups from your identity provider to access the resource, use service accounts to grant access between services, and you can specify access rules, at the IP level, sure, but also for users, groups, service accounts, down to the port and protocol that you have. In the continuous verification section, when you're adding users to your network, you can grant them access to the application in your IDP or explicitly approve who has access, and you can require users to authenticate after a set period of time. And for devices, Tailscale supports, macOS, Windows, Linux, iOS, and Android clients for end user devices. You can roll these out using an MDM. And then when a device joins the network, you can explicitly approve it, such as if it's in your device registry, and then use device posture management, which we just talked about, as part of access rules on an ongoing basis. To monitor your network, Tailscale provides you with several kinds of logs. First are audit logs of changes to your network. Then there's network flow logs. Since packets in Tailscale are end-to-end encrypted, this is the headers of those packets, but you can still see in that who connects to what and when. And you can then stream those logs to a SIM for further analysis. You can also record SSH sessions and play them back. And then lastly, Tailscale's policy engine. This is really the heart of how Tailscale works. And as I mentioned, the heart of something like a real ZTNA solution. We have a set of ACLs or a Tailnet policy file that allows you to really think about your network as being programmable. It's super powerful. You can have, like you have infrastructure as code, you can have your network as code. The Tailnet policy file gives you a way to make changes to your network via API, via GitOps, in a version controlled way, and even include tests to make sure that your network doesn't change from your desired configuration. The last thing I'll mention is or actually not the last thing. Second last thing I'll mention is how you get there, right? So one of the challenges that I've heard from talking to folks about moving to a zero trust solution is the difficulty in going from 0 to 1. We covered a huge range of requirements, and you don't need to get to all of them on day one. You don't need to adapt all of them on day one. So you can start small. So although you should and want to get to and this is a couple ways. So although you should and want to get to a fine-grained access control solution, if you are starting with a flat network, start with where you are and gradually segment your network more and more. If you're using Tailscale, Tailscale's mesh capable, which means that you can start with subnet level controls, and then when you're ready, refine that to the device level or even the port level. Since access control changes are pushed automatically down to all devices, you can make these changes whenever you want, right? You're not tied to a re-architecture, in some other part of your network in order to make these changes. You can start small with the number of people that you're working with. So Tailscale works well for teams of 10 people as well as for teams of 1,000 people. You don't need to roll it out across your whole organization to get its benefits. Test it out, adopt it with one team who's ready or has a higher risk profile without needing to roll it out to the whole company. And lastly, since Tailscale is software-based, not hardware-based, you're not tied to specific hardware, or maybe more importantly, hardware refresh cycles. So you can start adapting a zero trust network when you're ready to take on that project and not, in 2026, because that's when your firewall contract is up for negotiation, right? So there's nothing blocking you from starting this when it makes sense for you and your team. What I'll leave you with, we talked a lot about ZTNA and how Tailscale meets the needs of what you're looking for with ZTNA. But if you are looking at a ZTNA solution, why would you even consider Tailscale? So if you're already using Tailscale as a VPN replacement or a way to have remote access to prod, you're probably already familiar with what makes us different. Tailscale is a secure and private identity-based infrastructure agnostic network with a very flexible topology, resilient networking, and a streamlined setup. I know that's a mouthful, but that's how we think about it. That's what makes us different. When you're using Tailscale ZTNA functionality, you'll notice a couple of differences from other solutions on the market beyond just our ease of use. The first, like I just mentioned, is that you can iterate, so you can migrate iteratively and gradually. So we've really designed Tailscale to work for teams of any size. You can start with a small team. There's no need for a massive one-time operation. You can use us in a 50-person SOC or a one-person IT team. We'll scale with how you scale. We don't run any of the infrastructure that you depend on like you do. You have complete control. That means you get to control your business continuity plans and you get to control your trust radius. You can program and automate your network. So for DevOps and engineering teams in particular, everything can be scripted and automated with an eye towards something like GitOps, where you manage your policy effectively in Git and then push it as you make changes in Git. We strongly believe in privacy-led zero trust and privacy-led security. So since you run your network, you don't have to put faith in us that we won't snoop your data or rely on terms and conditions that promise that we won't. We've put in place controls so we literally can't. There's no proxies that we have to getting into your actual traffic, right? And lastly, you can deploy it anywhere. So, mentioned this a couple of times, but we're infra and network agnostic. Cloud providers, applications, databases, protocols, it'll all, no matter where you are, what your network looks like, it'll work with Tailscale. Tailscale is a zero trust platform that is designed to just work right out of the box and have a great user experience out of the box. So I encourage you to head over to tailscale.com and get started if you haven't used it before. Thank you so much for your time today, and I hope you learned something about ZTNA.